Okay folks, so I want to go ahead and do a video now on how to actually use these matrix row reduction operations to solve a system of equations. And this is one that we looked at earlier. So in a previous example we said, okay, we could put this into an augmented matrix if we wrote it as 3, -4, augmentation bar 1, 5, 2, augmentation bar 19. Okay. So I'm going to run through the algorithm and I'm just going to talk through it, and then once we're done we'll summarize those steps. So again, rather than spending too much time talking about the theory behind these steps, I'd rather just show you by way of an example how we're going to do them, and then we'll talk about them more generally after that. So this, what I look to see here is it possible to get a 1 at all ever in this position using matrix row operations? Well, there currently isn't a 1 here, but I could get a 1 here, and the way I'd like to do it is to go ahead and divide this row by 3. Okay. So whenever I do a matrix step, I like to annotate it with what I'm doing. So I'm going to go ahead and take, this is my current row 1, okay, and I'm going to say that my new row 1, and this is my own notation, I use a capital R for the new row 1, my new row 1 is going to be 1/3 of my old row 1. So this is going to tell me how I get from this matrix to the next matrix. So I'm going to take each entry of my old row 1, that's this row right here, and divide it by 1/3. Well, when I do so, I get 1 minus 4/3 and augmentation bar 1/3. Since I did nothing to row 2, I could just leave it alone, or if you really want to annotate it, you could say that my new row 2 is just my old row 2. So again, the new row 2 is just the old row 2, so I'm simply going to copy this line across. Usually if I'm not doing anything, I won't annotate it. Okay, so in the row reduction algorithm, in this Gauss-Jordan elimination procedure, I've now got a 1 in what I'm calling a pivot position. I'm not actually going to define a pivot position, I'm just going to show you by way of an example. So this is my pivot position, so now my goal is to get zeros above and below that pivot position. Well, there's nothing up above this pivot position, but there is an entry below this pivot position, and I want to get a 0 there. So there are many ways I could do some manipulation to try to get a 0 here, but I'm always going to do the same step, and I encourage you to always do this same step here. So what I'm going to do is I'm going to say that my new row 2 is going to be -5 times the current row 1 added to the current row 2. And that's going to help me generate the next row. Let's make sure that makes sense. What I'd like to do is get a 0 here. So because I took the time to get a 1 in this pivot position, if I simply multiply this row right here by the opposite value of this entry, in this case we've got a value of 5, so the opposite entry is -5. I'm going to multiply this row by -5 and then combine it to row 2 to give me a new row 2. So when I multiply 1 by -5, I get -5, add it to 5, and I'm going to get a 0 there, which is what I was hoping to do. Then I'm going to take this entry right here, which is -4/3. I'm going to multiply it by a -5. Well, that's a positive 20/3, and I'm going to add positive 20/3 to 2, so that's a positive 26/3 when I do that. Augmentation bar. Then I'm multiplying this entry by -5 here, so that's -5/3. And I'm going to be adding this to, oh, what is that, 57. So I'm going to be adding this -5/3 to 57/3, which gives me 52/3 for that entry. Okay. Now, again, I think of these as two separate, in this procedure, I first get a 1 in this pivot position, which is what I did between here and here. And now, between here and here, my goal is to get zeros all below this this pivot position here, and that's what I've accomplished. So we'll just copy this row over in this step. Some people can do multiple steps at once. I encourage you to have a step between here and here where we got a 1, and a step between here and here where we got zeros below that pivot. And I should say, even though we did zeros below and above the pivot. Okay, so I'm now done working on this pivot position here. So now what I do in the algorithm is I step one column to the right, okay? And I see if there's a way, so this is the next potential pivot position, and I see if there's a way for me to get a 1 here. And sure enough, there is. It's possible for me to get a 1 in this pivot position. How am I going to do that? Well, to get there, I'm going to simply divide this row by 3/26. So following my annotation, my new row 2 is going to be 3/26. Sorry, I said divide by 3/26. I should have said multiply by 3/26 or divide by 26/3. So I'm going to take this row right here, multiply it by 26 or 3/26 to the old row 2, and that will get me a 1 in that pivot position. So if I lost you on that, sorry, I stumbled over my words. Let's go through that a little more carefully. I'm going to take, to get this new row 2, which is going to be this row right here, I'm going to take the old row 2, which is this row right here, and multiply each entry by 3/26. Notice one of the important things is I'm not going to undo any previous work. When I multiply this 0 by 3/26, it remains a 0, which is what we were hoping for. Then I'm going to take 26/3 and multiply it by 3/26. That gives me the 1 in that pivot position that I was hoping for. That's the reason for this operation. Now I'm going to go ahead and multiply this entry, 52/3 by 3/26, and that's going to go ahead and give me an entry of 2 there. Okay. So next my goal is to go ahead and, well, let's go ahead and copy this over. So we get 1 minus 4/3 and 1/3. So between here and here, what did I try to do? Well, between here and here, I got a 1 in the next available pivot position. Okay. So now that I've accomplished that, what do I want to do? Well, I've got this 1 here. I now want to get zeros above and below this pivot position if I'm going for the full RREF form. So I want to get a 0 in this entry right here. How am I going to go about doing that? There may be other ways to do this, but the best way, the most systematic way, is to say, well, we took some time to get a 1 in this position. Let's multiply this row by the opposite sign of this coefficient. So I've got a 1 here. I'm going to multiply this row by 4/3, which will make that entry positive 4/3. And then when I combine it to this entry, it will give me the 0 that I'm after. So let's go ahead and annotate that. I'm going to get a new row 1 by taking 4/3, the old row 1, and adding it, the old row 2, which is my pivot row, adding it to the old row 1. Okay. Let's check to make sure that makes sense. So I'm going to get my new row 1, I'm going to use a combination, a linear combination of these two old rows. I'm going to take 4/3 times this row and add it to this row, and that will give me my new row 1. So see here, when we do 4/3 times 0, that's still 0, which gives us a 1. When I add it to that entry, it gives me a 1 in that position. When I multiply the second entry, 1, by 4/3 and add it to negative 4/3, that gives me the 0 that I was after. Then when I multiply the last entry, which is 2, I multiply 2 by 4/3, that gives me 8/3. I'm going to add it to the entry 1/3, which gives me 9/3, which reduces down to a 3. And I'm going to simply copy over the old row 2 now. So again, my goal was to get a 1 in this pivot position here, then zeros above or below it. Then scoot over a column, like I did here, and then try to get a 1 in this position, and then zeros above or below it. Okay? If it's impossible to get a 1 there following this argument, then this won't end up being a pivot column, and you'll see why when you encounter a situation like that. Okay? Now, as a reminder, why did we do all this? Well, this was a very structured and systematic way of solving the system of equations. Notice that these are all equivalent matrices, so each one of these corresponds to an equivalent system. I can't look at this system. I'm not good enough to look at this system and figure out what the solutions are, if there are any, to this system. However, that's equivalent to this system, which corresponds to the system of equations. This last one, let's see here, would be 0x plus 1y equals 2, or really, you can just read it this way as y equals 2. So I know that y equals 2 is a y coordinate of an ordered pair solution to this system. Likewise, we see this first row reads as x is equal to 3. So in fact, the solution is the ordered pair 3, 2. And that's how we can go ahead and give the solution to this system of equations. Yeah. What else do I want to say about that? Well, you could certainly check your work, plug in 3 for x and 2 for y, and you'll see, let's see here, 3 times 3 is 9, minus 4 times 2, so it's 3 times 3 is 9, minus 4 times 2 is 8, so 9 minus 8 gives us 1. That checks, but we've got to check the other one. So we plug in a 3 for x here, we get 15, plus 2 times 2 is 4, so we get 15 plus 4 is 19. So in fact, this does check. Okay. The last thing I want to say is that there's another way to now look at this problem. We could now rewrite this entire system as the system of equations as a matrix multiplication problem. So we started off with the entries 3 minus 4 and for the coefficients, and 5 and 2 for this. So if I took this, let me clean that up just a little bit. So if I took this coefficient matrix here, 3, -4, 5, and 2, multiplied it to our two solution and our solution vector, thinking of it as a vector, there's the operation multiplication there, you can confirm through matrix multiplication that this gives us the, so let's see here, this is a 2 by 2, and we're multiplying it to a 2 by 1, and sure enough the result is a 2 by 1, and you can check through matrix multiplication that we end up getting the solutions as desired. So this is the row reduction algorithm. What I've done here is I've summarized those steps. And I'll let you read through those steps, and we'll also look at them at the beginning of the next video.